Okay, so we are going to solve another question, and in this question once again we do a practice on work energy theorem. Okay, the question is, the displacement of, okay, let me write down the question. Okay, just wait, make it slightly bigger. Okay, a particle, wait a minute, a particle of mass uh, 2 kg, okay, 2 kg, okay, moving in such a way that its position from origin varies as uh, x is equal to t power 2, okay, t square. Find total work done in time interval time interval t is equal to 0 to t is equal to 1 second. Okay, we have to find the work done. Okay guys, here again we can solve this question by two approach. Let me come. Yeah, we can solve this question by two approach. By first approach, we can apply a Newton's law. Okay, we can apply Newton's law, and what can we can use, that F is equal to F is equal to F, F is equal, if first what can do, F is equal to ma. Okay, F is equal to m, and then by with this F we will get we will get F dot dr. Okay, and with the help of this we get work done. Okay, so work done. So let's solve the question by this first approach. Okay, so what here, so here x is equal to t square. So acceleration, what is the dx by dt, which is the velocity, this will be 2t. Okay, and dv by dt, which is the acceleration, and this will be the 2. Okay guys, so we know acceleration, and we know acceleration, then we know force. So what is the force become basically 2 into 2i. Okay, that will be 4 Newton. Force will be 4 Newton. Now after that we have to find displacement. Okay, we have to find displacement. So what is the if you look at this integration, f dot dr, or you can say f dot ds. So this here f is constant, so this become 4 and this become dr, so basically 4r. Okay, so we have to find r, we have to find r. Okay, what is the displacement? Okay, so at time t is equal to 0, time t is equal to 0, time t is equal to 0, the at time t is equal to 0, at r is equal to 0, the position is 0, and and time t is equal to 1, r is equal to 1. Okay, so what is the work done? So work done is basically 4 into 1 minus 0, that will be 4 joule. Okay, so this is the first approach. This, by this approach we can also find work done. In second approach, what can we do is, what we can do, uh, that change in kinetic energy, change in kinetic energy. Okay, kinetic energy is equal to work done. Okay guys, so if first time we differentiate it, okay, if we differentiate it, so what is the dx by dt, which is the velocity, so this will be the 2t. So what is the kinetic energy? Time t is equal to 0, time t is equal to 0, kinetic energy, sorry, velocity is 0, and time t is equal to 1, what is the velocity? Okay, time t is equal to 1, velocity is 2 meter per second. Okay, so what is the kinetic energy? What is the change in kinetic energy? What is the final kinetic energy? Final kinetic K2 is equal to half 2 into 2 square. Okay, so look, this is the 4 joule, this is the 4 joule, and what is the final? Ke1, Ke1 will be, okay, so and the what is the initial kinetic energy? Initial kinetic energy is basically, what is the initial velocity? Okay, so so this is the Ke1 is equal to half, mass is 2, and velocity is 0. Here look at this velocity, time t is equal to 0, velocity will be 2, what is the 2t. Okay, and this guys become 0. Okay, 0 at t is equal to 0. So initial kinetic energy is 0. Okay, so what is the change in kinetic energy? Change in kinetic energy is basically Ke2 minus Ke1. Okay, Ke1, that will be 4 minus 0, that will be the 4 joule. So this will be the change in kinetic energy. Okay guys, so yeah, whatever approach you may try, because here the both approach are nearly quite basic, okay, and quite simple, you can do it by yourself. Okay, thank you.